In this HVACR training video, we're going over condensate safety switch operation, installation, wiring, and testing. So we've got a variety of condensate safety switches here from Asurity by Diversitech. So we've got two versions here. We've got another two versions right there. Another one in the condensate pan. We've got a pump with an integrated safety switch, another condensate pump with a safety switch here, another pan safety switch, and yet another one right here. So now we're going to get into it. Before we get into this, I just want to explain what's happening. And you have hot, humid air crossing this indoor coil during air conditioning mode, and this coil is low in temperature. So the humidity is getting attracted to this coil, it's condensing and then trickling down into this pan. And so what you have is this condensate line is coming over here and going down into this condensate pump. But the issue is, in order for this water to trickle while it's running, you have to have water weight in this trap. Otherwise, you're going to be sucking air through through this hole right here. And the whole point is that this water weight is able to withstand the static pressure inside the ductwork of the system. So if you have water weight in here, as this water trickles into this pan, it's going to be able to continue to trickle and come out through the end of this tube right here. Now, an issue could occur if you have this trap right here being clogged. So you might have like algae growth or something like that clogging this trap. And what's going to happen is the water is going to back up in this pan, and that's why you have safety switches here or here in order to basically tell you if you have an issue. So these ones have an LED light, which what's going to happen is once one of these switches trips, then it's going to shut off the outdoor condensing unit, and so you're not going to have refrigerant running through this coil any longer. And then just say there was an issue where you didn't have your condensate safety switches here, you then also make sure you have a condensate safety pan down here. So that's also referred to as an emergency pan or a secondary pan, and in this case I have extra float switches down here as well. So we use multiple safety switches on a unit in order to protect the building from any water damage. So now I want to go and investigate each one of these switches individually. Now we're going to test these three switches individually, and I want to show you the water level it takes in order for them to trip. And so right here we're going to be able to see the water level. I'll slide that back over once you see the water level there. Now, as far as electrically speaking, we have a 120 volt over here to 24 volt transformer, and so you have your common attached right here to the side of this 24 volt contactor coil. Here you have your hot, and it goes right through this switch right here, and then it goes in through this switch, and then it goes through this switch, and then finds its way back over to the side of the contactor. So that's called series wiring. So the 24 volt power has to go through all three switches. Now we're going to turn the power on to this. And so you see we're measuring 25 volts on the side of the contactor. Now, if we were to have one of these trip, such as this right here, this is the test function, you see that that light gets lit. So this is a CS3 switch. So this will go on the second drain port, say on an evaporator coil, and you could just test it like that. What's happening is you're lifting a float on the inside of the switch. What you're doing when you pull this test switch is you're pulling this upwards and you're pulling the float towards the top. Now there's a magnet right there, and anytime the magnet comes up to the top, it is opening the normally closed contacts on the inside of here. And so right here, this is a CS-1, and this goes in a straight horizontal pipe. You see, once again, if this was to trip due to water, that light's gonna light up. And then right here, that has a light on the top as well. So there's a test function right at the top. Now we're gonna pour our water in, and so I'm just gonna pour it gently right into here. I'm gonna leave this basically slid off, but this gets mounted onto a horizontal drain that's normally not the flow point for the condensate. So this will be in some side section that you don't normally have water running through. So now we're going to pour the water in. So you know all of the electrical is on a GFI, so if any water splashes down, we are taking precautions right there. So we have, now we have water in this tube right here. It's just at a very low level. So you can see that both of those tripped right there. And we're only at about maybe the 1/2 to 2/3 level right here. So right where my fingernail is. So I want to make sure that you can see the water level. So you can see it is not very high yet. And just so we can see when these are going to trip, and then they're going to close back down right at about that height right there. All right, so you get to see those, and now we're going to slide this over. I'm just going to pull this up. Pull this one up too. Actually, you know what? What I'll do is I'll probably remove these. Now I'm going to slide this over. So you see this SOS-1 did not trip yet. The water level is not high enough yet. So we're just adding a little bit more at a time. And now you see it just shut off the contactor right here, and this light is lit. I don't know if you can see that or not. And so if we push to reset it, it's not going to reset due to the water height. Now let's look in here. You see that that tube is fully filled with water. So if we take this off, and then we press this reset, you can see then it's going to reset because it's not sensing that water inside the tube. Now this can get mounted on a clear tube such as this, or just a white 3/4 Schedule 40 PVC. Now what I did is I lowered the water height level to only about halfway full, and what I want to let you know is with this switch, it is adjustable. So what it'll do is it'll sense the water level, and you can basically lower the water height level down to very low, or say medium full, or all the way full based on the position of the switch. And so you can see that water level is right about here. As well, you want to make sure to not mount this in a location where it's going to be moist because it could give a false reading. As well, you could mount this on a vertical pipe and it'll sense once the water height level rises up to this switch. Now we're going to take a look at some of the other switches. Here we have the WS1 wet switch. A lot of people in the field refer to this as a puck. And so this right here, you have a red and black wire coming off of this that needs to be wired to the 24 volts on the transformer. So that's right here. Presently we have no voltage right here. I don't have this transformer powered, but so you have to have 24 volts here, and then you're going to be breaking the normally closed contact between green and orange. And so you see your orange right here, that's on your power, and then it has to go through the switch and then over to this side of the contactor if you're going to, say, break your yellow wire going out to your outdoor condensing unit contactor. This right here is just a jumper for your common from here to the transformer. And so we're going to go ahead and turn the power on to this. So we have our power on right now, so I'm not going to touch the back, but there's a piece of felt back here, and it wants to complete the circuit between two pieces of metal underneath of this felt right here in order for this switch to trip. But we can press this button right here, press to test, and so then we lose our power to the sides of this contactor coil. And then you just press to reset it, and therefore you have your 24 volts back again. So you want to have this breaking either the Y going to the outdoor contactor coil, or you could end up breaking the R wire going to the thermostat. However, you need to make sure it always has its 24 volt power input to this on the red and black wires. So now what we're going to do is we're going to splash a little water in here and see it trip. Alright, so it already sensed the moisture. You can see it's wet. And then now what I'm going to do is I want to turn the power off to this unit right here, and then we're going to dry the felt on the back of here and dry the pan. Now we're going to turn the power back on. So you can see it's already reset. I'll just press this, actually that one. All right, so then you see that we lost our power, and then we can just reset it like that. So that's how you take care of a wet switch that's tripped with a pan that has water in it. Here we have the AC shutoff switch. This is the CS1200, and there's a little test button right here on the side. There's a little micro switch on the inside, and then there's a float down in here. This bottom section can actually pivot, and so there's different angles on the sides, and so you can just swivel this over here. This clamp right here will fit on all of the different type of condensate pane lips that you may run into. And so we're just going to go ahead and snug this into place, and that's it. And so there, it's stuck right there, and then you have the bottom touching the pane, but the float is still up in the air. Then I'm going to go ahead and wire this. And now we're going to go ahead and turn the power on. So now we have 24 volts to the side of the contactor, and we're going to press the test button, and there's a little LED light right here that's lit. So that's telling you that the switch is tripped presently. Now let's see how much water it takes in order for this to trip the switch. All right, so right there, it looks to be about 1.25 inches. It's right here on the lip. And so you can see that this LED light is lit. So you can see we have another inch left in this pan. So the pan's definitely not going to overflow. You don't have to screw it into the pan. So this would sense any water in this pan and shut the outdoor condensing unit off to this unit. And now we're going to move on to the next switch. Here you have the Condensate Cop. This is a CC-1, and you have a wide lip here so it can get mounted to a variety of different pan styles. And then right here, this is the sensor, and it just gets tension fit right in here. And what we're going to do is I'm just going to mount this in place, and we tighten these 2 screws right here. And this, you can actually push this down and you can level it out. So depending on how deep the pan is, or if this is on a slight ridge where the lip is, this can still be mounted vertically. Now I'm going to go ahead and wire this in. And now I'm going to turn the power on. And you see the contactor is sucked in, but how we would test this is we would take this out and we would flip it over, and you can see what's happening right now is the circuit is open and it's not allowing power to the contactor. So we're just going to go ahead and set this back down in there. And there is no light on this, and this can be used to break either a R or Y wire for the thermostat wiring. And now we're going to see how much water it takes in order for this switch to open up the electrical circuit. Okay, so about 1.25 inches, and we have still about 1 inch of pan height left. So this pan would not overflow, and so the electrical circuit is opened up. If we were to lift this up, it would close the electrical circuit again, and the contactor will be powered, and now we'll press it back down again, and now the electrical circuit's open. Now we're going to move on to our next switch. Here we have the CS3 Pane switch, and this is meant to be mounted on the side of a metal pan, and it has plastic all-thread coming up, and so there's a nut here and a nut here, so you can rise it or lower it in the pan. And there's a float right here with a magnet inside, and when this rises, it'll open up the normally closed contacts. So I'm just going to mount this into our test pan down here. And I'm going to go ahead and wire this in. The power is off presently. Now I've already lowered this down. It's down all the way, and I'm going to go ahead and fill this up. But first we're going to turn our power back on. And now we're going to go ahead and pour our water in. I'm going to adjust this. So you notice that this switch doesn't require as much water in the pan in order for the electrical circuit to open up. Now this switch can be used to break the R or the Y heading to the thermostat. There is no LED on this one. Now we're going to take a look at some series wiring for the switches inside of an HVAC unit. So now we're looking at the inside of a gas furnace, and so this set of thermostat wires right here is for your indoor thermostat, and this set of wires right here is going to your outdoor condensing unit. And so this is actually going to the outdoor contactor, and it's going to look just like this in the outdoor unit. And so this is not normally in here, it's just rain. It's in the electrical compartment of the outdoor unit. I want to explain though what's happening with the wiring. And so you can see that this white wire right here is attached to the common, and this one is attached through 3 safety switches, and then it comes back to the Y terminal. So the Y and the C are what goes out to the outdoor contactor, and what happens with this thermostat wire is R is your 24-volt power from the control board. Anytime R touches G in the thermostat, it turns the indoor blower on. Anytime R touches W, it turns heat on. Anytime R touches both Y and G, it's going to turn air conditioning on, so it's going to turn this indoor blower on and turn on the outdoor contactor. So what we can do is we can put our safety switches in to open up the electrical circuit to the contactor, which would shut off your refrigerant flow so that we don't have condensate overflowing out of the pans or out of the evaporator coil pan or our secondary pan. So presently we have our Condensate Cop down here. In the secondary pan we have our switch on the condensate pump right here, our overflow switch, and we also have our SOS1. So that's our 3 safety switches. So these are in series in order to break the Y wire going to the outdoor contactor. So first I want to measure our voltage going from common over here on our thermostat to the R. And so you read 27 volts. And the only reason that we have power down here is I actually have the door switch pressed in. And what I'm going to do now is I'm going to take this and put it on the Y. So we want to measure for voltage here. We're not going to have voltage until the thermostat touches both R and Y together. So here we go. So you can see our contactor sucked in. We have 26 volts between common and Y. And now what I'm going to do is I'm going to actually take this off, and I'm going to clamp it right down here. I'm going to turn the power off first, maybe. Nope, we got it. All right, so 25 volts. And so we have our common here, so we could take this off too, and we could measure right here. So we got 24 volts. Now let's go ahead and trip this safety switch right here. And you can see we lost our power to the outdoor contactor. So that's how this works. Now you see we have power to the contactor, but also we do have power to the blower motor right now, but I already removed the blower motor wire because I didn't want that noise to disrupt us while we're looking at air conditioning mode. But we are getting power to both the G for the indoor fan and our Y for the outdoor contactor. I just have the indoor blower motor wire disconnected. So what we're doing is we're breaking the Y wire to the outdoor contactor, but depending on the switch type, you can break the R wire going to the thermostat instead. So let's take a look at that wiring. So presently we have 3 switches in series, and we have no LED lights or control boards right now, and I'm just measuring resistance between right here and our red wire going into the R terminal of the thermostat. You see we are happen to read 0.5 right now. But when we flip this over, it's going to open up the electrical circuit, and so we read OL, and then when we close that back down again, our circuit is completed again. So now I'm going to turn the power off to this right here, and I'm going to connect into here. So now I have the multimeter set on voltage for alternating current, and we have on our transformer, this is our power going to the T terminal, and we have our common going to the C terminal. So we have power going through the T, through the fuse, and then over to the R. Then we go through all 3 of these switches in series over to the R terminal on the thermostat. I'm measuring voltage between the R and the common, and so we're measuring 27 volts. And so if I was to pull up on the test function right here, you see our voltage drops, and we no longer have 24 volts, we actually have 18, but that circuit is open. So same thing right here. So anytime you measure on both sides of an open switch, you're going to measure maybe about half the voltage you normally would. That's just because your multimeter is completing the circuit. You actually do not have power in order to complete a circuit. So anyway, that's just to show you that each one of these switches are opening up the electrical circuit. So with these switches, you could break the Y wire, but in this case, we're breaking the R wire. So if the thermostat did not have batteries, that thermostat would go blank if a switch tripped. If you want to learn more about the safety switches used in this video, make sure to check the links down in the description section below. Also, make sure to check out some of the free resources we have over at acservicetech.com, where we've got quizzes, calculators, we've got articles, quick tips, and also the podcast. Make sure to also check out our Refrigerant Charging, the Service Procedures for Air Conditioning book. We have a 1,000-question workbook to go along with it, and we also have quick reference cards that we use in the field. These are made out of polystyrene, so they hold up really well. So make sure to check all that out over at acservicetech.com. Hope you enjoyed yourself, and we'll see you next time at AC Service Tech channel.